right, you guys, question number 8 also asks us to solve it. What it means when it asks us to solve it is what number can I make the variable to make this equation true? So what I'm going to do for this one is I'm going to start on the right-hand side, and I'm going to simplify here. So I'm going to do this subtraction. So thankfully, what I notice is that if I factor a p out of here, what I get is, let's just do it below and then I'll rewrite it. If I factor a p out, I get p plus 1. And the reason that's important is because this denominator over here is already p plus 1. So actually, all I have to do, I don't have to do anything to the first fraction, right? I don't have to do anything to the first fraction. I'm just going to call it, I'm just going to factor that out and call it p plus 1, okay? All I have to do for the second fraction to make them the same, because they already have the p plus 1, is to multiply it by p over p. Now I have a common denominator. And then what's really cool, I'm going to rewrite this whole thing because I noticed that over here, this is already p times p plus 1 also. So now this is equal to 1, and I'm just going to go ahead and make that common denominator. My denominator is p times p plus 1. And then the numerator is, don't forget this is a negative, so I need to put parentheses around here, and then I need to distribute it. So 1 minus p, but then minus negative 6, which is actually plus 6, right? And since I already know they have the same denominator, those are going to cancel out, right? Like I did last time. If I multiply both sides by both denominators, like that's how you solve a proportion, which is what I have here, times p plus 1, okay? These cancel out here, right? Because I'm just multiplying the entire equation by the one variable, right? I could have done it like by both denominators, but that seems like an extra step to me because I'm already multiplying the entire equation by the same thing, so you don't have to do that. Then what you're left with is p plus 5 is equal to, let's combine our like terms, 7 minus p. And then how about I add p to both sides and subtract 5 from both sides, and I get 2p equals 2. So p equals 1. Right? So p is equal to 1. Let's see, what does that make the left-hand side? That would make the left-hand side 1 plus 5 over 1 squared 2, which is equal to 6 over 2, which is just equal to 3. So my left-hand side is 3. Let's make sure that that's what my right-hand side is equal to. So 1 over 1 times 1 plus 1, so 2, so 1/2. Okay, so we have 1/2 minus, and then what happens here? We have also over 2, because we know that's got to stay the same. We have the same denominator. And then 1 minus 6 would be negative 5. And then this p is just 1 out here, so we don't need to change that at all. So 1/2 minus negative 5/2, this is equal to 1 minus negative 5 is positive 6 over 2 is equal to 3. So it matches. My left-hand side matches my right-hand side if I make p equal to 1. So let me go back to what I did in this step. Let's make it pink. In this step here, where I was multiplying, and I want to show you, okay, because I want to show you how that works with just like a regular ratio so that you remember. Now, if I have 1/2 is equal to x over 4, I would multiply both sides by both denominators. That's why I was saying I should have really multiplied it by both, but it didn't matter because I was multiplying by the same number on both sides. But what I meant by that is here I would multiply by x over 4 times 4, but also by 2 because I have two different denominators, right? And over here by 2, and then also by 4. This is how we solve ratios unless you're cross-multiplying. Both are correct ways. So here my 2's cancel. 4 times 1 is 4 is equal to, and here my 4's cancel, and 2 times x is 2x, so x equals 2. Now, what if instead of 1/2 equals x over 4, I had 1/2 equals x over 2, right? Well, then I could multiply both sides by both denominators, but I'll show you why that's an extra step, okay? So here we have just the 2's cancel, and here we have just the 2's cancel, but now I have 2 times 1, which is 2, is equal to 2x, and I just need to divide both sides by 2, and I get x equals 1. Well, that's going to be the same if I had just used one of the 2's, right? If I had just used one of the 2's, this would be extraneous, and this would be extraneous, and I would still have x is equal to 1. Also, I hope you noticed, if the denominators are the same, like I said in the very first question, if all of the denominators are the same, we know the numerators have to be the same. If I have 1 over 2, and I have that's the same thing as another number over 2, that other number has to be 1, right? So many different ways to think about this. Send me a reminder if you have any questions. Good luck studying, get some good sleep, and have a good breakfast, and I will see you when you take the test.